In this video, you'll be introduced to the idea of how to prove that a quadrilateral is a parallelogram. Now, there are a lot of different ways that you can use in order to prove that something's a parallelogram, and they're listed in the box on this page. So it says the first possible way that we can prove that something is a parallelogram is to show that both pairs of its opposite sides are parallel, or in other words, that it meets the definition of what it means to be a parallelogram. So again, this is the definition. The second possibility is to show that both pairs of opposite sides are congruent. And again, I want you to notice the difference between the first reason, which is to show that they're parallel, and the second reason, which is to show that they're congruent. The third possibility is to show that the same pair, so either the top with the bottom or the left and the right, is both parallel and congruent. You can show that both pairs of its opposite angles are congruent, or you can show that it's a diagonal or a quadrilateral whose diagonals bisect each other. When working in the coordinate plane, we really have the greatest amount of flexibility as to which one of these methods of proof we're going to pick. So that's where we're going to start. In example 1, we're given quadrilateral ABCD that has those vertices, and we're being asked to prove that it's a parallelogram. And again, I can show that it meets any of the criteria in that box above, and by doing so, it will be a parallelogram. I'm going to go ahead and I'm going to start by graphing the points that have been given to me for the vertices of the quadrilateral. So there's A, there's B, C, and D. So that's what our shape looks like. And again, if I wanted to go with the first option, I could show that top side is parallel to bottom side, left side is parallel to right side, making, by definition, the figure a parallelogram. I could use distance formula to show that left side and right side are congruent, top side and bottom side are congruent, making it a parallelogram because both pairs of opposite sides are congruent. I could use slope and distance on either the top and the bottom to show that the top and bottom are both parallel and congruent, or to show that left and right are both parallel and congruent. There really isn't a way in the coordinate plane to show that both pairs of opposite angles are congruent, so that really is the only method I could not use here. But the method that I'm going to pick and to go with is I'm going to show that the diagonals bisect each other. And the way that I'm going to show that they bisect each other is by showing that they have the same midpoint. So I'm going to do a little bit of midpoint formula with this particular example. So midpoint, remember, is the average of the x values, or the sum of the x's divided by 2, and then the average of the y values, or the sum of the y's divided by 2. And I want to find the midpoint of each diagonal. So I want to find the midpoint of diagonal BD first of all. And as a math teacher, I'm pretty good with the mental math. But if you're not, just take your calculator and plug these numbers into the calculator, and your calculator will give you a nice answer that you can feel good about. So for BD, I'm looking at a midpoint of -1/2. And now I have to go find the midpoint of the other diagonal, which is AC. And again, I'm pretty good with the mental math, but if you're not, just grab your calculator and type in the fraction, 3 plus -4 for the numerator, 2 for the denominator. It's going to tell you -1/2. And type in the fraction whose numerator is 4 plus -2 and whose denominator is 2, and it's going to tell you 1. So again, it's a little bit hard to discern from the graph because these two diagonals don't cross at a specific point, and that's why I'm going to use the midpoint formula to figure it out. These two diagonals share the same midpoint, and what that tells me is that they bisect one another. So since these two diagonals share the same midpoint, and the fact that the diagonals bisect one another makes ABCD a parallelogram. I'm going to go back and reword that to say making. So again, I chose to show that it fits into that criteria number 4, which is really criteria number 5. Any quadrilateral with diagonals that bisect one another has to be a parallelogram. But again, I could have chosen one of many different methods for my proof. Excellent. So that's how your proof might look in the coordinate plane. How about a Euclidean proof? These are sometimes more difficult because we have to use the information that has been given to us. We have a lot less flexibility than we do when we're working in the coordinate plane. If we're given that these two triangles are congruent to one another, we want to now prove that FLHS is a parallelogram. And I'm noticing that this figure was named badly. It should be FLSH. I'm going to go ahead and say that yellow triangle is congruent to the green triangle because it's given to us that they're congruent. And if they're congruent, I know that the top side of my figure has to be congruent to the bottom side of my figure. And if I go look at the criteria above, I'm probably going to want to work with this number 2 because that has both pairs of opposite sides congruent, or the other number 2 because that's got the same pair of opposite sides both parallel and congruent. So again, I want to work with one of those methods that deals with congruent sides. Unfortunately, there's no way for me to get the left side of this figure congruent to the right side because I don't know anything about those triangles over on those sides. But I do know that angles 1 and 2 are congruent by CPCTC. And if 1 and 2 are congruent by CPCTC, that's going to make the top side parallel to the bottom side. So now I've got the top side congruent to the bottom side and the top side parallel to the bottom side. So that fits very nicely here in my second criteria number 2, which talks about the same pair of sides being both parallel and congruent. So that is really the only strategy. I don't have a choice here with respect to this example number 2. All right, so I'm going to go ahead and I'm going to start with my given, the two congruent triangles. And from those two congruent triangles, I can really discern two things. I can discern that the top side, LS, is congruent to the bottom side, FH. And again, that's just CPCTC. And because of the congruent triangles, I know angle 1 is congruent to angle 2, again by CPCTC. In the diagram, angles 1 and 2 are a pair of alternate interior angles that are congruent. That makes their respective lines parallel to one another. So that makes side LS parallel to side FH. And the reason for that is the congruent alternate interior angles make lines parallel. So now I've got the same pair of sides, and it's important that they be the same. In one statement, they're congruent to each other. In the other statement, they're parallel to one another. So again, that fits the criteria or the second criteria 2 from my list. That will make my quadrilateral FLSH a parallelogram. The reason for that is any quadrilateral with the same pair of sides both parallel and congruent. And again, it's important that they be the same pair. That makes that figure a parallelogram. So this certainly isn't a very long proof by any stretch of the imagination, but I think it's a conceptually difficult proof. And part of what's going to be difficult about proving that a figure is a parallelogram is examining this list and figuring out where in that list or which category in that list this falls under. All right, as always, thank you for the gift of your time. I do want you to, on the next page, summarize the most important key ideas from this lesson and see if you can take what you've learned to prove that quadrilateral on the next page a parallelogram.